Okay, let's continue. We are now going to chapter 2. Okay, just to summarize, what is chapter 1? Chapter 1, you're dealing with motion, which is distance, velocity, acceleration. There's no mass. If you see the question do not give you mass, then it's not chapter. No mass means it's chapter 1 question. If you start to see mass, it's chapter 2 question. Okay, now just to give you an overview of chapter 2, basically chapter 2 is using F equal to ma equation. That is chapter 2. Yeah. Okay, chapter 2 is using Newton's second law of motion, which is F equal to ma. Okay, what is the 3 Newton law? See if you can remember. First Newton law, say what? Is object is at rest, it continues at rest. Yes, stay rest or continue to move. Second is F equal to ma. Third is got reaction. Means if you reaction and action force. Means something that if you have an action, then there will be a reaction. Okay. Now throughout this chapter 2, it actually is a very short chapter. And we'll go through 3 coordinate system. We'll use rectangular coordinate, means x and y, and then we will go through normal tangent direction. Normal tangent means we focus on the object. And we'll go through cylindrical coordinate, means r and theta. And centrifugal force, space mechanics. This one we don't go to space mechanics, but we'll go to central force motion, means centrifugal force. Right. Okay. So this one you already know. Basically focus on F equal to ma for chapter 2. So when you see the question, m is given. Once m is given, you know that it's chapter 2 and onwards, and you need to use F equal to ma equation. All right. And once you have m, then the gravitational acceleration effect take place. Means you need to convert m into weight. W equal to mg, like what I mentioned in the previous class. You need in your free body diagram. So chapter 2 onwards, you need to draw free body diagram already. Okay, so the first equation for chapter 2, F equal to ma. F equal to force equal to mass multiplied by A. And in this case, for chapter 2, your mass doesn't change. There's no change of mass. Okay, for space, you are using F equal to G, M1, M2 divided by R square. It's a gravitational attraction, but you will see this one when in your senior year, maybe year 3, second sem, or 4th year, first sem, when you go into satellite operation, right? So M1, M2, and then there's a R, you calculate the attraction force between the 2 objects in space. And the G here is not 9.81, the G here is 66 minus 12 meter cube over kilogram second square. All right. Okay, so but anyway, this is not the focus point. It's just introduction of gravitational attraction on second Newton law. So basically, you can write this equation equal to this one. Just go through. You don't need to remember this one. Just to how we derive equation from here into F equal to ma for space application. Right? So here, our force in gravitational, we only focus on weight. So F become W, and this term become mg. And then you cancel out, you can equal the terms together. Right? So from here, on the space operation, once you know the mass of one body and the radius, the distance between the two body, and you know the gravitational attraction force, then you know how many G you have. Right? But this is not the focus of chapter 2. It's not the focus, it's just an introductory for chapter 2. This is important. Start chapter 2 onwards, the mass effect under a gravitational force will create weight. Again, weight is go through all the center of mass, which is at the center of the object. No matter what is the shape, it's always at the center. And the arrow always pointing down. So in the previous diploma, some of the diploma students, they still don't know how to draw W direction. Some still draw pointing up, W, and so on. All right. So for aerospace student, this is a common sense. All W will be going down straight, and you write W equal to mg. Acceleration always going down, and it's equal to gravitational force. Okay. Then we recall back the vector calculation. So if this object in the dot project, we still at the kinetics of particles. Kinetic of particle means we see the body or the object as one big sphere. Everything sum in one sphere. So here you have two forces or external forces pulling in two different directions. And they, in this case, it's a perfect case where they are pulling at the right angle. So you can find the resultant force by combining the two vectors. This one, if you don't know, go to the appendix C and appendix B. I think it's appendix C in the island, right? Vector analysis. I give you the appendix already. Go through, read through if you don't understand what is vector. Okay, now for chapter 2, you need to always find the sum of the force with sum F equal to ma. So on the left-hand side of the equation, always you write sum F equal to F1, F2, F3, F4, and so on. Then equal ma, right? Okay. Now, chapter 2, you need to draw two diagrams. One is free body diagram combined with kinematic diagram. So what is free body diagram? Basically, free body diagram is only dealing with forces. Kinetic diagram is deal with motion, mass, and acceleration. So in chapter 2, you need to, sometimes we combine, sometimes we break them away. But as you go through more and more questions, we always combine the two diagrams. Right? So again, what is important is on the left-hand side is your F. On the left-hand side of your equation in chapter 2, you always find forces. On the right-hand side of the equation, you always find acceleration or the motion vector. Okay, so in chapter 2, you always refer to your free body diagram and kinetic diagram. Means they are marks for free body diagram and kinetic diagram. That's why in your free body diagram, we will see forces and also velocity acceleration arrow. Okay. So at the end, we combine these two. We want to see F equal to ma. This one. Then onwards, we will break the right-hand side or left-hand side into x-axis, y-axis, cylindrical position, polar position, and so on. Okay, so this is the general concept. The rest is just mathematics. Okay. Now, this is already know already in chapter 1. every time we do analysis, we have a reference point, and we always label our reference point as O. And the path of particles, the direction. From this chapter 2 onwards, your positive direction always follow the motion. If the object moving to the right means right positive. If the object moving down, down positive, and so on. If you deal with mass, if you deal with mass. So your equation F equal to ma will follow the motion direction, because we try to avoid negative sign. Yeah, follow motion. So follow the motion and object. Okay. Now this is just for info. Just for info. So as we go detail, we can break one object into many small parts that give you I individual component. And each component, if you take out, let's say this dotted is one body, and you pick one is one individual, each individual because of mass, so mass have force effect. Okay. So this is just an introduction, what is expected in your answer. So you always need to show the free body diagram, which is the force component, and the motion component of kinetic diagram, the A direction, ascending direction, or the motion direction. From the question, already know what is the direction already. Either go up, go down, left, right, and so on. Okay. So again, chapter 2, you need to have two diagrams. For starting, you start with two diagrams, and then as you move forward, you will combine these two into one, just to save time. Okay. This one you can skip. Okay. Still F equal to ma equation. Still F equal to ma equation. Okay. Recall back what you learned in the statics. Central of mass. Central of mass, you take m, multiply the distance to the gravitational point. In this case, let's say the Rg is to the center of mass of that object. So you take m, multiply r, equal to sum of all the individual mass and multiply by the Ri. So you differentiate this equation. R is the distance. You differentiate 2 times of the distance, you get acceleration. Yeah. So you convert ma to the center of the mass, you'll get forces, because second Newton law tell you F equal to ma. Yeah. So this, it will be, we keep repeating F equal to ma. That's the whole point. The whole point. And if you 3-axis, you can break your force into 3-axis equation. You can break into x, y, and z. So your left-hand side equation is F. So you can break your force into all the force in x in I direction, all the force in y in j direction, all the force in z in k direction, equal to m. Mass doesn't change. So mass doesn't change, is a constant value. Bracket, acceleration have direction. So you have x direction in I, y direction in j, and z direction in k. So in the question, you need to identify whether it's 2D problem or 3D problem. If 3D, then you have involved k. If it's 2D, then you only solve I and j. Right? So chapter 2, basically, you resolve, once you see the vector, you resolve into x and y direction. Then you solve x direction, solve the x problem, then you solve y direction. Okay? So basically, when you see the question in 3D, straight away, you write this equation, general equation, all the force equal to MA. Next step, you write all the force in X equal to MAX, all the force in Y, Fy equal to MAY, all the force in Z equal to MAZ. This is the first step for chapter 2 question. All right? You write, this one got marks on, this one, 1 mark, this one, 3 set become 1 mark. So here got 2 marks, 3 marks. The rest is substitution. It looks simple, but sometimes you overlook this one. You will have a tendency to go and solve and substitute value inside there. All right. Okay. We see the first question, F equal to MA question. You read the question, you know it's chapter 2 question because mass is given. Right, mass given 50 kilogram. And this one is, although it looks like 3D, but it's a 2D problem. It's pulled at a 30-degree with P equal to 400 Newton. Show at rest in the horizontal surface with a kinetic friction is given. So kinetic is given means there's a normal force and friction force. If the crane is subject to a 400 towing force, determine velocity of the crane in 3 seconds from the rest. This is basically combining the 3 Newton equation, because if you pull at a constant force, your object accelerates at a constant acceleration. F equal to ma. First, you build 2 sides of diagram. You can write FBD or free body diagram. If you're lazy to write the long one, you can write FBD in your answer. And another side, you write kinetic or kinematic or kinetic diagram or KD, right? So you copy the shape of the object, or you can just replace as a big dot, right? But it's good that you follow the shape, because here is a with the contact surface. So you draw the object in square. On the left hand side, always all the force. Right hand side is always the motion. So you copy from the question the forces with the angle 40. Follow the datum. Copy the datum from the center. So another one addition is just to, because you're given the weight always pointing from the center of mass. There's a difference between center of mass and center of gravity. Okay, but later, that one later. But we now focus on center of mass first. Right. Okay, center of a mass, W equal to the weight effect or weight force equal to mg. This is standard. Every time you see object with a mass, then the additional force there is W. And then there's a contact surface, always pointing up, not pointing down. Why the arrow is pointing up and not pointing down? Yeah, why? You know it's normal, but why the arrow is pointing to the surface and not away from the surface? Why? Okay. More easier way is you think yourself as the box. What do you feel if you touch the ground? The ground is pointing to you. That's why normal force is pointing out. Okay. More easier way lah. Then you have a normal, then you have a friction force. So friction equal to mu n. And mu k, we use mu k because the question asks you, it start to move already. Okay. And not mu s. Mu s is in statics. In dynamic, we use mu k. Okay, once you solve with the force diagram, free body diagram, you go to kinematics. You write equal, and then copy the same shape, and you predict the direction. Direction, if you pull P to the right hand side, so the object will move to the right hand side. So the force will be along the motion which is MA in that direction, into the right. Okay. Don't change the direction to up or down. Huh? So this MA is along the horizontal datum that given in the diagram. Then you call, once you have the diagram ready, free body diagram and motion diagram or kinetic diagram, then you go to F equal to MA. Standard step. Huh? Once you have that, you write all the force in X equal to MA, not zero. In static, it's zero, but in dynamic, not zero. Don't write F equal to MA equals zero. No such thing in dynamics. In static, all the force in equilibrium because the object doesn't move. But dynamic, the object is moving, so the force is not zero. Okay, you write these two equations because it's 2D dimension. You write all the force equal MA, got 1 mark. All the force in Y equal to MAY, another marks. This is 3 marks. Tell me where is the direction, positive direction. This is a common habit. You need to tell me where is the positive direction. So X to the right is positive, Y going up is positive. Okay. Then you put in all the value you know from the diagram. Extract from the diagram. So left-hand side of the equation will be from the left-hand side diagram. So what are the force in X direction? Friction and P in X direction. You need to split the P in PX and PY. So PX is 400 cos 30 to the right, positive. However, friction is always opposite or resists the motion, so it's to the left. So negative 0.3 NC equal, right hand side of the equation is you need to refer to the kinematic diagram. So here only see MA. So M is 50 kilogram multiply acceleration. Okay. So here got two unknown, NC and A. But you have two equations. So don't rush, but you solve Y first. Y, 400 sine 30, you convert the P into PY, PX. So here you solve for PY. PY going up. However, W go down. MG, 50 multiply 9.81. Don't use 10. In degree, G is always 9.81. NC, point up. Careless mistakes, always the NC. Careless mistakes, always the NC. NC will always missing in the solution. So don't miss that NC. So from the second equation, you can solve NC, right? Once you solve NC, substitute back, you get your A. This is solving simultaneous equation. I won't go deep into the calculation, but that is the concept how you solve chapter 2 question. Draw diagram, force diagram or free body diagram and kinematic diagram. Use F equal to MA equation, break into X direction, Y direction or Z direction. Solve that 3 equation or 2 equation, solve simultaneous equation, then you get the answer. That is the step for chapter 2. So I won't go through the steps of solving. NC equal to 900 or 200 something in the unit of Newton. Then solving for A is 5.185 meter second square. Unit important. Unit important. If the answer is 2 marks, without unit, you only get 50% of the answer. And still, we are solving vector problem. What you see here is not just a number, but with direction. Okay, now we already solved NC and A, but the question asks us to find velocity. So because acceleration is constant, it's not an equation, then you can use the 3 Newton equation. You can either use either 3, but the most simplest one is V equal to VO plus ACT. V you don't know. VO is 0 because question say that it start from rest. So VO, or some of the textbook use U, V and U. Substitute, solve the question, and then point to the direction. Give me a direction. V is to the right. Okay, that is the common step for chapter 2. Okay, next question, you just observe the steps. See if you're able to solve. You're given a scenario. A bullet was shot up, given a mass 10 kilograms. So this is chapter 2 and onwards question. With initial velocity, VO is given or U is given. Determine maximum height at which it will travel. Two scenarios. First scenario is air resistance is ignored, means there's no drag. B is you're given a drag equation where V is the speed of projectile at any instant, measured in meter per second. So what is your focus of this question? Is it the cannon or the ball? The ball, right? The cannonball, right? Or the bullet. So you convert the bullet shape, you copy the bullet shape round, and then put in the force. So first step is to draw the free body diagram and kinematic diagram. Okay. You draw two diagrams. Observe, so to observe. On the left-hand side diagram is all the force that apply to that body. On the right-hand side is the motion. All right. So the first one is W for sure. W always go down. You write W equal to mg. Is there any other force? What other force? No more, right? No more forces. Kinematics. Direction of motion is what? Go up, right? So draw the cannonball shape. Put in the motion. What is the motion? MA, yeah? MA, go up. So you write MA is the force, actually. MA, the multiplication of mass multiplied acceleration equal to forces. So that's why left-hand side is forces equal to forces. That's why these two are balanced. Don't just write A. It's not equal to A. It's equal to mass multiplied acceleration that give you Newton, that give you forces. Okay. Once you have this one, after the diagram, the next one is you write F equal to MA. This one, you only have one direction. So you solve for Y direction only. Okay. Or in this case, it's Z lah. You need to look back the question. If the question point to you, Y is Z, your answer have to write Z. If you write Y or X, I will circle and put the question mark then. Where is Y or where is X? Notation is important. Direction is important. Left-hand side is the equation. Refer to the free body diagram. Right-hand side of the equation, look to the kinematics diagram. Substitute only. Left-hand side, you only see mg. And again, direction is important. Mg pointing down, negative. This will be the careless mistakes. Some of you, you write positive. You are dealing with vector. So go down, negative, go up positive, equal to MA. A go up positive. Yeah, because your general direction, you already fixed already. Go up positive. F equal to ma equation, you already define. Go up positive. So you need to refer your general axis. You can solve for your A. So your A is 9.81. Negative means that it's going down acceleration. So once you get acceleration is the constant value, then you can use 3 Newton motion equation. Yeah. Again, this is the third set of equation. 3 Newton equation, you have 3 equations. So this is the third one. V square equal to VO square plus 2AZ or 2A delta S or changes of displacement. A you have V is given, VO is given 50 meter per second. VO is given, AC is given, Z you know. This is Z, right? Z minus ZO, ZO is 0. So we have two unknown there. You have V and Z. VO is given. Okay, why I can write VO equals 0? Because it asks you to find maximum height. You know that one object, when it reach, we throw up at the maximum height, VO equals 0, V equal to 0. So some of them, you are stuck here. You cannot find V. It's a common logic thinking. So you have to think how the object behave at a certain thing. This one you see in the chapter 1 tutorial also, the rocket problem. Okay, so here you can find the Z. Basically, it's 3 steps only. First, draw the diagram. Second, apply F equal to ma. The third step, solve the unknown. And then tell me the direction. And that's it. It's chapter 2. We always repeat these 3 steps. Okay. Okay. What happens if you have a air resistance? Air resistance. What happened to your free body diagram? What is the direction of air resistance? What about pull down? What up? What is the motion? It's like a friction. Should be go down, right? Drag will pull you down, right? It's like you're moving, but then something drag you back, right? Always opposite of your motion. You have to lock this one down, right? So imagine you are the cannonball, you moving forward, but something pulling you back. So the force is at the back, right? So you observe, right? So the drag force is along the center of mass. So the important, you know where to point the arrow, the forces. You imagine yourself at that object, and then what do you feel? Then it will tell you the direction. If you feel something dragging you, then you know the direction. Something pressing you, then give you another direction. Then kinematic is the motion, is only always the direction. M multiply A. Don't miss the M. Don't just give me A. You need to write MA because these two are in the Newton unit. So these two are equal, they are equal to each other. Next, you write F equal to MA. So in this case, you only have one direction with Z. So going up, going up positive. Then look at the diagram, solve for the F for the left-hand side of the equation. Copy what you see in the kinematics diagram on the right-hand side of the equation. In Z direction. You focus on Z. Of course, example 2 is a direct tutorial question. In the test or final exam, you'll be given an angle. So always split your force into X and Y. That's it. Okay. So once you substitute the value, you can find your velocity. So minus 1.1 v squared is going down. Remember, some of you will miss out the negative because it is going down. So you get a one equation. This equation constant acceleration or not? No, right? So you cannot use the Newton equation. So how? Once we arrive at this equation, A equal to minus something and something. So it's not constant because you're having a quadratic equation here. So your acceleration is depending on the velocity. Acceleration A bracket inside there got velocity term. A is depend on velocity. Can you recall what is the definition of velocity and acceleration? ds, the acceleration definition A equal to dv dt. And one more is there's one equation A ds equal to v dv. You still remember there's one equation. When you log the time dt dt and then you rearrange the equation. Okay. V definition ds dt. A equal to dv dt. You write the dt to the left. Dt. Two are the same. So this side equal to this side. dsv equal to dv a. A to the left, v to the right. You arrive at a dv ds equal to v dv. This is from the definition of v and a that you learned in chapter 1. So this is where if you do not get your constant acceleration, you need to recall back to the basic with its definition of acceleration and velocity. Either you do differentiation or you do integration, depending on the cases you have. So here you have ds, dv or dz, dv. You know that you see this one, you can integrate already. Yeah, once you see the equation got d something equal to d something, next step is integration. So you put in the equation. A is given by this equation. So substitute the A inside here. dz v dv. So you know that the v is, you need to put together, right, when you integrate. So pull the v square over right hand side. So when z 0, this is a boundary condition. When z is 0, v equal to 50. When z equal to maximum height, velocity equals 0. You have the boundary condition here. So you do integration. This one become this one. Make sense, huh? You just rearrange the equation. Then integrate that one. I will skip this step. This is the integration steps. I assume you already know, so I won't go deep that. What I need to highlight is the limit that you use in the integration. Z is from 0 to maximum height. Velocity here is the careless mistakes. You start with 50, not 0. Some of you put 0 and then write 50 here. The question already tell you start with 50, then end with 0. Careless mistakes is here. So always, if you know something, you write on the question or answer the condition that you have. Then you do integration part. Your homework, integration. The homework is a bit lengthy. You get your z equal to 114. If you substitute all the parameter in, it involves some ln equation because it's 1 over something. 1 over V. All right. So if you, since you already have ChatGPT, you can ask ChatGPT to solve this one for you and then show you the steps. All right. Okay. Basically, I just repeat the 3 steps. First, draw the diagram. You have 2 diagrams need to draw. Free body diagram and kinematic diagram. Then next step, write F equal to ma. See what is the direction. If it's 2D, then you have solve X and Y. Then you find the unknown. Okay, now the example 3 is the datum pulley question. So why this is chapter 2 question and not chapter 1 question? Because chapter 2 question you start to see mass already. Okay, now you're given a mass of object A, and then if the mass of the pulley and the cord can be ignored, determine the velocity of block B in 2 seconds. Block A is 100, block B is 20 kilo. Which one drop? A drop, B go up. So this is a common sense that you need to have, because A is heavier, A will pull down, B will go up. Okay, so just to recap, every time you see pulley question, you need to recall the pulley question steps. First, find total length. Yesterday we mentioned, once you see pulley question, first step, look at the datum, and then find total length. LT equal what? So LT equal to, how to find the total length? SB plus SA. Once you have the total length, next step is to differentiate with time, change S into V, ds dt, then you get VA and VB velocity, and then differentiate one more time, become acceleration. Okay, that is chapter 1 calculation. But chapter 2, you need to draw diagram. So here is to find what? B. Okay, means you draw, this one you focus on, because it's asked, the question say the mass of pulley and the cord can be ignored. So there's no mass effect on the pulley, but there's a mass effect on A and B. So you look at the pulley and you imagine yourself as a pulley, and what do you feel? You feel 2 forces pulling up, and then A is pulling you down. This is a full free body diagram for pulley C. Write as T form. Okay, so this one pulley C is tension cable. The cable tension on the pulley C body. Okay, so when you see problems of pulley, solve the tension first. Solve the tension on the cable first. Okay, then okay, how to draw kinematics of pulley C? Where will be the direction of pulley C? Go up or go down? Go up. Okay, I draw the A first. Pulley and the A, mass A. Mass always have W. And the T here, I write 2T because from this diagram. Careless mistakes will be here. You will assume this one as T. It's not T, it's 2T. Yeah. Okay, this one is to show you the tension. Why is 2T? Why this diagram pulley is important? Because you will assume this one is one tension cable. Careless mistakes will be here. If you do not draw this diagram, you don't draw pulley C diagram, you'll put T here. Okay, you imagine yourself as a pulley. What do you feel? You feel something pulling you down, right? So the arrow is going down. Yes, there's a rope there. Okay, but still we focus on the mass. Kinematic diagram, A will be go down. We follow the motion, the direction will follow the motion. A always follow the motion, go down positive. Yeah. So when you see pulley question, remember to go and see what is the tension at that pulley, and then connect that back to the object for free body diagram. Yes. This, if you do not draw this, your free body diagram, you will write T here and not 2T. How you get 2T is usually it doesn't make sense. You straight away write 2T. It doesn't make sense on the first reading, right? Okay, and then because of the pulley system, remember to put in one more marking. Datum for A is go down positive because the datum arrow go down positive. This is a bit extra if you see pulley question. Remember to add this one in the diagram. Once you able to do this one, the next step is F equal to ma and solve F equal to ma equation. Okay, the hard part is this one. Usually the careless mistake will be the tension and the direction of the A. You cannot imagine where does it go. Then you randomly you give an arrow. Okay, so we continue. Mass B. I should put away the C already. Okay, mass B, where is the tension? There's one tension cable, right? If you're B, you feel something pulling you up, right? So the tension is this one. What is this? 2T or T? T, yeah. Why? Because this cable connecting to B. This cable and this cable is the same. This cable and this cable is the same. Okay, so the pulley tension cable diagram is important. Every time you see pulley, draw the pulley first, and then you put yourself as the pulley, and then what do you feel? Equal. What will be the direction of B? Going up. But here we assume is go down first. We assume. Okay, SB go down. All right, we assume. You know that it's going up. You know it's going up. All right, but you assume it's go down first. Once you find this one, if you write this like this, later your answer for AB will be negative. Again, this direction either go up or go down. Follow the datum. Follow the datum. Follow the datum. Yeah, for pulley question, you imagine if you cut the rope, what will be the object going? All right. Then you solve F equal to ma. This only one direction, which is y direction. You solve one mass by one mass first, right? So on the left of the equation, you look at the free body diagram. And here, our motion go down positive. we set F equal to MA, direction go down. Why? Because of datum. Because of datum, because we always want to put a line with the datum direction. This one? Oh. Okay, another set, like Justin question. Okay, so it can be if the datum is from here, you will see the arrow, this one point up, SB. Then you need to follow datum. Okay, A, we are solving for A first. You're going for A first. Okay, so you just copy what you see in your free body diagram and kinematic diagram. Left hand side, you have mg minus 2t. Why minus? Because you motion, you assume go down. Is equation of motion, you follow motion. You follow the A direction, the SA direction, right? If you ask Dr. Can I put go up positive or not? Can. No issue one. Is that your answer will be negative later? Okay. So you put inside there, substitute value, and you get an equation, a certain t equal to acceleration of A. First equation you get, right? This for A. Then you solve for B. Same, F equal to MA, go down positive. Okay, go down positive. Again, why positive? Because our datum is go down positive, and motion, we assume go down positive. Or you can say that you assume everything go down is positive and for the general datum or for general axis. Since all the beginning, you assume go down positive for this question. So you refer to the diagram, go down is positive, so mg minus t, and you solve for two questions. You have two equations, but you have three unknown. You have three unknown, you have P, you have AA, you have AB. You need one more equation, which is from the chapter 1 pulley question, which is total length, that equation. LT equal to SB plus 2SA. How you differentiate that, you get something like that. So, okay. So you get this one, you differentiate it, L is 0. L can't differentiate, becomes 0 because total length doesn't change. Then you write 2AA equal to minus AB, which makes sense. Because if you A go down, B go up, there's a negative sign there. So different position, different direction, makes sense. If here you get positive, then something wrong in your derivation, in your equation. Okay. So here, just put here, you assume all direction go down positive. So you have three equations, solve three simultaneous equations. I will skip that part. You substitute solving three simultaneous equation. This is 1, this is 2, this is 3, third equation here. Solving these three, you get A, B, and T. That part, if you don't know how to do, then you need to go back to your mathematics lecturer. Okay. The answer, T equal to 300 something. A is 3 something. B is minus 6 something. Yeah. But still, you do not answer the question. It asks you velocity. So because the acceleration you get is the constant value, is not an equation. So you can use the 3 Newton equation, 3 Newton motion equation. We pick the simplest one, which is V equal to VO plus AT. So since the question asks you about the B, you rearrange or modify a bit the question, change the substitution or the subscript for acceleration become B, and you get the velocity. Velocity is minus because direction go up. Because you assume all direction go down positive. So again, in dynamic, you get negative means direction is opposite of what you assume. Okay. Yeah. The next, I'll go very fast. I'll go very fast because you already know already. Next one is more on the tangent and normal direction. Normal tangent means you focus on the object. You focus on the object body and the collinear motion. And we apply F equal to ma. So you have 3 equations. FB equals 0 because it's a 2D planetary question. Right? FB equals 0 means you have a 2D problem. 2D issue to solve. Right? So, okay, just observe how we solve. So you have a scenario where the object is tilted at a certain degree and moving outside the screen. You need to find the track. You need to design the track for this car so that the car do not slide in. Do not slide down when you speed up, right? So that the wheel of the racing car do not have to depend on the friction to prevent sliding up or down. Assume car, you can ignore the size, ignore the mass, and travel around the curve of the radius with the constant speed and v. Okay. So what do you do? Draw diagram. Just observe the steps. Ignore the value. First, the T is go outside the screen. Normal and tangent. The car is coming out from the screen. So the tangent is coming out from the screen. V is going up or down, and then W go down. This is the tricky part. Who don't understand why arrow N is like this? It's the contact surface of the car. So it's at a certain degree angle. You need to find this angle. Of course, you have to later you need to derive why this angle equal to this angle. There's a transpose of angle. Okay. And I combine the kinematic diagram also on the same diagram. AN to AN direction. And because this is a collinear motion, so you solve with F equal to ma. F equal to ma, you solve by direction. You solve by n direction, or you can see it as x direction. X direction, you have how many force in x direction? Only nc cos 30. Right? Not sine, sorry. Sine 30, sine angle in n direction, and then cos angle in b direction. So here is focus on n and positive direction to the n direction. So you have this equation. N sine theta And why I can write mv squared over rho? Because in the collinear motion, you convert ma, the a is v squared over rho. You get the first equation. Second, b direction. So NC, you split into b direction, you get cos theta. And the W, and then there's no AB. The car do not fly up, right? Okay. So you get a second equation. The rest is solving simultaneous equation. Okay. You need to polish up your skill how to draw free body diagram and kinematic diagram. Then F equal to MA, solve for the specific direction. Then unknown. Tangent is coming up from the screen. I got sound one. Okay, so you need the third equation. You need the third equation because here you got NC and the G. Who don't understand how you get tangent? How you get tangent equation? Recall 1, 2, 3, equation 1, 2, 3. How you get tangent? Tangent equal to what divided by what? Sine divided by cos, right? So you take equation 1 divided by equation 3. You eliminate NC. You take away NC by division. You take sine divided by cos, you get tangent. Eliminate NC, and you only arrive at b squared over GP. Rho you have, v you need to find, and so on. So tangent is in the equation form. So your test 1 question will be in the equation form. Next hour is got class. What class? No class. Okay. Okay. The next one. Sabar. Okay. Example 3, example 5, go home and read. There's a tricky part. Example 5 will be your final exam standard. Go and read. Okay. Example 6, also go home read. Go on read. Example 6. Okay. I just want to highlight, every time you see curvature motion, you need to use V squared over rho. Every time you see curvature things, a quadratic equation or polynomial equation, you need to use V squared over rho. Every time you see a curved motion, which is in the x square. And this one is, we need to use this one because R is not given, or the radius is not given. Okay, go home and see. If you have a question, come and ask me. Okay, cylindrical equation, cylindrical coordinate also same, but now you are in the R and theta direction. Okay, still F equal to MA, but in the R, theta, and Z direction. It's the same, it's still the same, just change axis. This one I skip. Okay, this one, try to observe. The step always same. Free body diagram. Axis. You need to focus what actually the question asks you to solve. On the diagram, there are many parts. Focus on that particular component. Then solve for the forces. First step, free body diagram. Second, solve F equal to MA. This is if you see r dot, theta dot, you need to use the equation will be given. So don't worry if the question asks you about theta r or cylindrical coordinate, the equation will be given. This one, your homework, go and read. This one also, go and read. Homework, go and read. Okay, with this, we conclude chapter 2. I love this.